These notes are on finding the center of rotation. The first one that we're going to work on is finding a center of rotation for a point and its image. So just a reminder, back in Module 5, we talked about how the perpendicular bisector, that line, plays a very special role to the endpoints of any line. So I'm going to talk about the definitions that are up here, but first let's actually find the perpendicular bisector of n prime. So you can, but you don't have to, connect the points n and n prime. So I'll do that just for the sake of some of you may find that visual to be very helpful. So there's my line n prime. And now I'm going to find the perpendicular bisector of that. Remember, to do that, I'm going to need a compass. Make an arc above and below. My compass is open more than halfway between n prime. And I've put my stylus, my pointy part, on n prime. Make an arc below and above. Then I put my stylus, my pointy part, on n. Make an arc above and below. I may have to go back and redo my first arc so that I get those arcs intersecting very clearly. Once I have those arcs intersecting, I am going to draw in the perpendicular bisector. So now let's talk a little bit about this definition that's above. What this definition tells us is that if I pick this point on the perpendicular bisector, it is going to be the same distance to n prime as it is to n. If I pick this point on the perpendicular bisector, it is going to be the same distance to n prime as it is to n. If I pick this point on the perpendicular bisector, it is going to be the same distance to n prime as it is to n. So what that means is that the center of rotation that maps n to n prime is every single point along this line. So I'm going to make it officially a line by putting arrows, and I'm going to give it a name. The name I'm going to use is a cursive L. And so now we want to say that the line L contains all the centers of rotation that map n to n prime. So when I'm finding the center of rotation for a point mapping to a second point, it's a line. It's infinite. I can have all of those centers work. And all of the centers lie on the perpendicular bisector of the line that connects the pre-image point to the image point. The second problem that we have talked about when finding the center of rotation is no longer looking at just a point and then its image, but actually looking at a whole figure and its image. So the thing is that I can find all of the centers of rotation for a prime. So that's what I'm going to do. I'm going to find right now all of the centers of rotation for a prime. In this case, I'm not going to connect a prime. That way I have fewer lines to confuse myself, since I sometimes get easily confused with all my lines when I'm doing constructions. I'm also going to place my stylus as much as I can to the center of that dot A, because the dots on this picture are big. Where I put my stylus is going to make a difference in terms of the precision that I get. So I am going to make sure it's open more than halfway, and it's open almost, well, let's see. Yeah, I think it's open more than halfway. It's going to be a little tight. So I make an arc above and an arc below, and then I do that same thing from A prime, below and above. I see my point right there, but on this side, on the bottom, my arc is a little too short, so now I've got the arc fully connected. Now I'm going to draw the line in using a straight edge. And so this line right here, this is all the centers of rotation that map A to A prime. So there's all the centers for A to A prime. I'm going to do the same thing now for C to C prime. I want to find all of those centers. So in this case, C to C prime is a little bit wider than A to A prime. So I'm going to open up my compass just a little bit here. So it's more than halfway actually works here. I'll make an arc above and below, an arc below and above, and I have to redo this first arc a little bit because it wasn't long enough. So I'm going to use a slightly different color ink. I'm going to use red, and I'm going to connect my perpendicular bisector. And I'm going to note that this is all the centers of rotation that map C to C prime. Now I need to find all the centers that map B to B prime. So let's double check here. That looks like it's about more than halfway. Probably going to be a little tight again, but that should do. So I make an arc above and an arc below. Then from B prime, I make an arc above and an arc below. And my below arc looks a little too short on that side. I'm now going to use a third color. And I'm going to draw in the perpendicular bisector. And the green line are all the centers of rotation that map B to B prime. So now we have three lines. We have the line that represents all the centers of rotation that map A to A prime, a second line that maps has all the centers of rotation that maps B to B prime. Just add the arrows. And then we have a third line that has all the centers of rotation that maps C to C prime. So if you notice though, all of these three lines intersect in one point. So this one point is the point that works as a center for mapping C to C prime. It also works as a center to map B to B prime. And it also works as a center to map A to A prime. Because it's the one point that works for all three of them, that is the center of rotation. Center of rotation that maps triangle ABC to triangle A prime, B prime, C prime.